All right, today we are diving deep into Java Swing. The original GUI toolkit that basically built a whole generation of desktop apps. But why on earth should you care about it now? Let's get into it.
And look, that is a totally fair question. I mean, we live in an age of web and mobile apps, right? So why are we digging up a UI toolkit that's over 25 years old? Well, here's the thing. The ideas behind Swing, the core concepts and architectural patterns, they are surprisingly timeless. The stuff you learn here, it's going to help you build better apps today, whether it's for a desktop, a phone, or even a tablet. So to really get why Swing is still so important, we've got to jump in the time machine and go back to the beginning. Let's see what made it such a huge deal in the first place.
At its heart, Swing is this really powerful and honestly super flexible toolkit for building rich graphical user interfaces, GUIs, for desktop apps, all in Java. We're talking about creating sophisticated, professional-looking applications from the ground up. Okay, so what is Swing, technically? Well, it's part of what's called the Java Foundation Classes, or JFC for short. And you gotta know, it was created to be a massive upgrade over its predecessor, the original Abstract Window Toolkit, which everyone just called AWT. And the huge, game-changing difference between the old AWT and the new Swing, it all boils down to this idea of heavyweight versus lightweight. See, AWT components were heavyweight. They were tied directly to the operating system. They had to ask Windows or Mac how to look and feel. But Swing components, they're lightweight. They're written entirely in Java. They don't ask for permission. They paint themselves. This was a huge deal for flexibility and making sure your app looked the same everywhere. All right, so that's the what and why. Now let's get into the how. How do you actually build a Swing app? Let's break one down and look at the nuts and bolts, kind of like taking apart a gadget to see how it works. Okay, check this out. On one side, you have the final result, a simple Hello World window. On the other, you have the code that makes it happen. You can probably already spot the connections, right? There's a main window, there's some text, there's a button. Let's dig into what each of those pieces of code actually represents. So think of these as your Lego bricks. Every Swing app is just a collection of these components. The JFrame, that's your main window, the whole frame with the title bar and the close button. JLabel is, well, it's a label, perfect for displaying text or an icon. And the JButton, of course, is the button you click to make something happen. Now, if those components are the bricks, you need some mortar to hold them all together, right? In Swing, that's called the containment hierarchy. It's basically a big tree structure. You have your main window, the JFrame, at the very top, and then you just start adding all your other pieces, your labels and buttons, into it. The key thing to remember is this. If a component isn't in this hierarchy, you're just not going to see it on screen. Simple as that. Okay, every system has its rules, right? Its own laws of physics, and Swing is no different. In fact, it has one golden rule, one rule to rule them all, that controls everything about the user interface. Seriously, if you take away only one thing from our chat today, make it this. And here it is, the golden rule. Swing is not thread safe. So what does that actually mean? It means only one single thread gets to touch, modify, or update the user interface, ever. If you break this rule, if you try to have multiple threads messing with the UI at the same time, you are asking for chaos. I'm talking flickering, apps that freeze up completely, and just bizarre random errors that you will never be able to track down. So to avoid all that chaos, Swing has a brilliant solution. It has one special thread that handles all the UI work. It's called the Event Dispatch Thread, or the EDT. And here's a great way to think about it. Imagine your UI as a canvas, and the EDT is a single, super meticulous artist. This artist is the only one allowed to paint on the canvas. They handle every single brushstroke, and they respond to every event, like a button click. You wouldn't let two artists work on the same painting at the same time, right? Same principle. So how do we make sure we're playing by the rules? How do we talk to our artist? We use a special tool, swingutilities.invoke later. When you wrap your UI code in this, you're essentially handing a note to the artist that says, hey, when you get a free moment, could you please paint this for me? It guarantees that your request gets handled safely on the correct thread without causing any problems. All right, so we know the golden rule. Now, what happens when we break it? Let's talk about some of the most common pitfalls people run into and, more importantly, how to get out of them. You've probably felt this pain before. This is the #1 question every new Swing dev asks. Why does my UI freeze up when I click this button? You click it, expecting something to happen, and nothing. The whole app is just locked solid. So what's going on? The cause is exactly what we've been talking about. You've blocked the event dispatch thread.
You gave our poor artist a really long, boring job to do, like downloading a huge file or running a slow database query. And because the artist can only do one thing at a time, they have to stop painting completely to finish that task. The result? A frozen user interface. The canvas is just stuck. Thankfully, there's a fix for this, and it's a fantastic little helper class called Swing Worker. It's like an assistant for our artist. You give the long, heavy lifting task to the Swing Worker, which goes off and does the job on a completely separate background thread. This frees up our main artist, the EDT, to keep the UI alive, responsive, and beautifully painted. Okay, next up, another classic headache. You've spent all this time adding your buttons, your text fields, your labels, and it just looks like a mess. They're all jumbled together, and even worse, when you try to resize the window, everything goes haywire. What's the culprit here? 9 times out of 10, it's because you're not using layout managers. See, it's tempting to try and place everything by hand, setting the exact X and Y coordinates for every button, but that creates an incredibly brittle UI. The second someone resizes the window or uses a different font size, the whole thing shatters. The right way to do it is with layout managers. Think of them as intelligent designers that automatically arrange your components for you. Something simple like a border layout is perfect for dividing your screen into 5 main regions: north, south, east, west, and center. But when you need real power for a complex screen, Grid Bag Layout gives you this super flexible grid system. The payoff is huge. You get an organized, professional-looking UI that adapts and resizes just like it should. Okay, so we've covered the mechanics, but let's zoom out a bit. Swing might feel a little vintage, but the ideas it championed, the architectural patterns it brought into the mainstream, man, they are more relevant now than they have ever been. Swing was really built around the classic model view controller pattern, MVC. The whole idea was to separate your data, the model, from your user interface, the view. But this created its own challenge. Sometimes the view got way too smart and complicated. And that's where we see this really cool evolution to patterns like passive view. The big idea there is to make the UI as dumb as possible. It has zero logic. It just sits there and does exactly what a controller tells it to do. And why is that so great? Because it makes your code incredibly easy to test and way easier to manage long term. So when you look at the timeline, you can really see this story unfold. Java GUI development kicked off with AWT back in 1995. Then, just 2 years later, Swing comes along and completely changes the game. And then, fast forwards 2008, and we get JavaFX, which is really the modern successor. But the key is that JavaFX was built on all the hard-won lessons from the entire Swing era. And that really brings us to the big takeaway here. What is Swing's real, lasting legacy? Is it the specific buttons and labels? Or is it the deeper architectural lessons it taught a generation of developers? Things like how to handle a single-threaded UI model, or the critical importance of separating your logic from your view. These are principles that go way beyond just one toolkit. They apply everywhere, which just goes to show you, good architecture never goes out of style.